Hi friends, every day of your life is a priceless gift to you from God. Use every second for self-improvement and humanity. Good morning everyone. This time, we will discuss one of the questions from the previous year's selection. This question is quite long, so we will give you a few seconds to read and understand it. Do you have an idea about this question? Let's start with a short animation. There is a ball and a billiard table wall. What's interesting about this billiard table? That at the top of the table there is a kind of part that protrudes to the left. Of course, this part will come into contact with the ball later. The ball rolls to the right without slipping at a speed of u. Eventually the ball will hit the wall. After the collision process, the ball rolls to the left at a speed of v. From this data, we are asked to estimate the height of the protrusion on the billiard table wall. Now we understand this question. Let's discuss it. Let's first determine the height of the protrusion on the wall. The height is h. From the side of the ball, we can assume the ball has a radius of r. The ball will hit the protrusion on the wall. This means that the height h must be less than the diameter of the ball. If the value of h is greater than the diameter of the ball, the collision process will not occur. This is true. If the height of the protrusion is less than the radius of the ball, then there is a possibility that the ball can pass through the wall. This is not in accordance with what is meant by the question. Because after the collision, the ball will roll in the opposite direction, not through it. From here we know that the range of height h is greater than the radius of the ball, but less than the diameter of the ball. This is what we wrote on the question sheet. Next, we will analyze the movement of the ball. The ball rolls to the right. If we understand the concept of energy, we will definitely know that the speed of the ball will decrease. Now here we can assume that the value of the speed is constant. The speed is u. This is the linear velocity of the center of mass, not the angular velocity. So while moving from left to right, the velocity of the ball is u. So, when it hits the wall, the velocity of the ball is u. Let's say the ball hits the wall at this point. The protrusion is pointed. The surface of the ball hits the wall at one point. If you've ever watched the impulse and momentum course on the channel, you'll know that the wall will exert an impulsive force on the ball, opposite to the direction of impact. Since the ball hits the wall to the right, the direction of the impulsive force is to the left. After impact, the ball is moving with a velocity v to the left. So there's something at the point of impact. When there's a change in the direction of the ball, there must be a torque. This torque is what can change the direction of the ball's rotation. Torque is produced by impulsive force. Let's take a closer look at the point of impact. We can extend the lines of force. Well, the distance of the perpendicular line from the axis of rotation to the line of action of the force is the torque arm. The length of the torque arm is h minus r. Torque is the rate of change of angular momentum. Mathematically, we can write the torque as vector r cross vector F equals dl dt. Since vector r and vector F are perpendicular to each other, the magnitude of the torque is Rf sine of 90 degrees. The length of the torque arm is h minus r. The sine of 90 degrees is 1. Now, let's remember the concept of force in general. Newton himself stated that Newton's laws are more appropriately expressed in terms of the rate of change of linear momentum, dp dt. There is a factor of dt on both sides, we can ignore that. dp is the change in linear momentum, final momentum minus initial momentum. dl is the change in angular momentum, final angular momentum minus initial angular momentum. The final linear momentum of the ball is m times minus v. Remember that the direction to the left is negative. The initial linear momentum of the ball is m times u. For angular momentum, the final angular momentum is I omega final. The initial angular momentum is I omega initial. Since the ball is rolling without slipping, we can write the angular velocity as the velocity divided by the radius of the ball. We can write the equation like this. I is the moment of inertia. The moment of inertia of the ball is 2 over 5 mr squared. M times v plus u is the same value. We can cross that value out. Now h minus r is equal to 2r over 5. We can group similar quantities. H is equal to 7r over 5. This is the height of the protrusion on the wall of the billiard table. A question like this seems easy, but it's not that easy. We need mature knowledge related to the concepts of force, momentum, angular momentum, and torque. Before closing this tutorial, this video is indeed available for free, but the process of making a video like this requires a lot of money. You can support this channel by subscribing to this channel, of course. Hopefully useful. And don't forget to watch the next video.